Consider the velocity time graph below. So we can see that we have velocity in meters per second on the vertical axis and the time in seconds on the horizontal axis. The gradient of a velocity time graph gives the acceleration. Acceleration is change in velocity divided by time. That means it's v, that's the final velocity, take away the initial velocity, so that's the change in velocity, final velocity, take away initial velocity, divided by the time taken. So as I said when we were looking at the formula, v is the final velocity, the velocity at the end of the time period we're looking at. U is the initial velocity, that's the velocity at the beginning of the time period we're looking at, and t is the time between those 2 points. The area under the graph gives the displacement. So if we look at the motion here, again it's the same velocity time graph, then along this section the acceleration is the change in velocity over time. We can see the final velocity here is 10 and the initial velocity was 0. So that's going to be 10 divided by 5 because it took 5 seconds. And that gives me 2 meters per second squared. If we look along this section, the velocity is constant, so the acceleration would be 0. The object is moving at a constant speed of 10 meters per second along this section, and that's how we know it's not accelerating. We now look at this section. The acceleration is the change in velocity over time, and we can see the initial velocity this time is 10 and the final is 0. So that's negative 10 divided by 10 because it took 10 seconds, which is negative 1 meters per second squared. Now consider this area. It's a triangle. We can see the base is 5 and the height is 10. So the area is 5 times 10 divided by 2, which is 25 meters. Remember, the area gives us the displacement. We then have this rectangle. The area is 5 times 10, which is 50. And then we've got this triangle, and the area is 10 times 10 divided by 2. Base is 10, height is 10, and that also is 50. And therefore the displacement in this case is equal to the distance covered because the particle was always to the same side of its start point, and that's going to be 125 meters, so we just added up those 3 areas. We'll have a look at a situation where the displacement and distance are not equal in the examples to follow.